So we have our logic to check if it's a win or if it's a draw. Otherwise, we are going to continue the game when our user clicks on the specific port index. So what we want to do now is to start building our online part so we can share this between the users and actually start making our game work as it should. So there is one last thing missing before we can play online, and this is our player ID. Because right now we don't have a ID for each player. I don't want to call them player 1 and player 2. So we're going to create a local user or local player object that will be saved on our device itself. The player object will have only an ID, which is going to automatically will be generated automatically. And this ID will represent our player and its games. So we are going to use the ID in order to get other games and to join a game or to create a new game, etc. So let's go to our model. You can put it here or you can create a new file. Let's just do a new file just to keep everything clean. We'll call this a user. And I'm going to just simply create a struct of user or a player, whatever you wish. This is going to be codable because I want to save this in my user defaults. And this user is going to have just an ID and it's going to be of, let's automatically assign 1 as we initialize uuid string. Here, if you want to keep a name of the user, score, how many games they played, how many wins, you can put the variables here like var name is, I don't know, empty string, and then user can register or put the name here, etc. But to keep everything simple here, I'm going to just have a local user with a unique ID. Otherwise, if you want to keep the score and the name, etc., you will need to register the user, save the user online as well. So when, for example, you are in a game mode, other user can see the name of the counterparty, maybe see how many games they have played, what is their win, lose score, etc. This is totally up to you if you want to build on top of the current project and make it like real, fully functional 100% game that you can play or even post to App Store so the users can play. This course will be very, very good foundation on the game. So if you want to build and add on top of that, you can do that. So our user will just have a ID, and yeah, we need to create one and save. So let's see where we are going to do that. I'm going to go back to my game view model. And as soon as we initialize a game, let's quit this one. When I initialize a game here and I enter the game view, here we want to make sure that we have a local user. If we don't have a local user, we need to create one because we will need the ID of that user in order to join any game, or if there are no available games to join, we are going to create a new game. What is how the steps will work in terms of the logic, we will talk again once the time comes. Right now I want to focus on the user. So whenever we enter our game view, and remember we are entering our game view from the home view, and as soon as we initialize a game view, we are initializing a view model object. So in our view model object, I can put an init function that as soon as this is called, our initializer function will be called as well. So before we process any move, I am going to say init, and we can put anything here we want, and this function will be called as soon as our game view model is initialized. To set our user, we need first to have an access to our user defaults. We are going to save our user there. So on the top here, I'm going to access the app storage environment. And we want to access a user. This is the keyword for my user. This is where we are going to save it in user defaults, which is in SwiftUI. It's an app storage. And I'm going to call this private var user data. And it's going to be type of data. Because everything is saved in our user defaults, or the app storage in our case here, is a data file. And once we get that data, we can convert it to a user object. Where is it? Because this is conforming to codable protocol. So we just create a user struct here. So to get back to our game view model, and once our game is initialized, we want to check our user defaults if there are any user already saved there. And if there are, we want to get it and convert it to a user object. So let's create a published var current user. And this is type of user. And this is not an optional, because if we don't have a current user, we cannot play our game. So that's why this cannot be an optional. If we don't have this, we can crash our application. The user cannot play a game, and period there. So on initialization, we want to do two things. We want to check if there is already saved user in our user defaults, and if there is, we will get the data and convert it to a user object. If there is no, we want to create one and save it. So let's create two functions. First is going to be called like retrieve user. I'm going to do it at the end here. And the second one is going to save in case if we don't have anything. So I will put a mark here, call this user object. And we have func save user. And a func which will retrieve. All right. So retrieve, first we want to start from this. We want to access our user data. Basically this user data will get an access to our app storage where it's under the key user. So if there is something in our app storage, which is the user defaults under this key, it will equals to our user data. Otherwise, this will be a nil. So we say here guard. We don't want to try to assign anything to create a user object from the data if our user data is nil, otherwise it's going to crash our application. So we say let user data is equals to user data, else we want to return. Okay, so we make sure that there is a user data there. If there is, we want to convert it to a user object. So we say current user is equals to, and we need to try to decode whatever this is to our user object. I will say JSON decoder dot decode from, and we're going to say user. What we want to decode is user self. So we will decode a user object from user data. And this may throw, so we better put this in a do and catch block. So if there are any errors, we want to know about them. So we say print, and let's say I don't know, no user saved. All right, And I will also put a print here, and we say the coding user. Okay, so that we know what's going on here. So this will be our retrieve. And in order to save user, we are going to say our current user is equals to new user object. And remember, when we create a new user object, we automatically assign its ID, which we just create a new UUID and assign to it. And the reason I'm doing this is I straight away set the value of my current user to the new user object that we are creating. So our application will be ready to play with that set new user. While we are doing on the background, we are saving it into our user defaults. So when we start the second game, or we just tomorrow we play another game, we will have this already stored in our device. So I will say again, to catch block here. And what we need to do is now actually the opposite of here we did for our retrieving. We try to take the data and convert it to a user object. And now we want to take our user object and convert it to a JSON and save it. So this was a decoding. Now we need to encode our user. So I will say let data is equals to try JSON encoder, because we want to encode our object to, let's say, encode, and this is throws. We want to encode it to current user. So we take our current user that we set it, and we convert it to a data. So we encode it. And then we say user data is equals to our data, or you can cut the chase. User data is this one, remember, which will in its turn set it into our app storage environment. Or you can just, I don't know, take this part and put it here straight away. This is a little bit more readable, so I will keep it this way. And print, let's say print for error, say couldn't, actually we need save user object. Okay, so we have these two functions. Let's call them in our initializer. The first one, we want to always try to retrieve our user. So I will say retrieve user, and then after we retrieve, I will check if my current user is still nil. So I say if current user is nil, then I want to save a user, which in its turn is going to create a new user. So after retrieving, if our current user is still nil, so there was nothing there, we will create a new user. Let's say here also print and coding user object. And let's test this. So right now there is no user saved on our simulator. So once I click this button, we will be able to try to retrieve. There will be no user, and we will save it. So it says encoding user object, and it says decoding user object. So because this printed initially, because our retrieve user was nil, and then we got our user saved, and we got our user ID also. We can test this. Let's in our initializer, I will say print. We have a user with ID, and say current user dot ID. So let's see if we already have a user. Right now we should have one. We have a user with ID, and this is our user ID. Remember the numbers here, and if I rerun, we should see the same ID. Yeah, so this doesn't change. But if, for example, I quit my game and I actually delete the game, which in its turn is going to delete our user defaults, now our ID will be regenerated and our user will have a different ID. You can see it starts differently. So every time we start a new game after our new installation, there will be a different user ID here, which is good. Let's get rid of this. And our initializer is set. We just want to make sure that we have a user object in order to be able to play our game. Right, in order for our game to be multiplayer, we need to pass this game object around. So it should be somewhere on the cloud that it's accessible for both players, so we can keep the game up to date. In order to do that, we are going to use Firebase, because Firebase can provide us real-time updates on whatever is going on the database, and our game should be real-time. So this is really what we need here. To get started with Firebase, if you haven't done anything with Firebase before and you are not familiar, you need to go to your browser. I'm using Chrome here. Just go to console.firebase.google.com, and as long as you are logged in with your Google account, it should be fine. Otherwise, you just need to register with Firebase. And once you are here, and this is the first time, you should see only this card here, add project. Otherwise, you can see all other projects you have already created. You can see I have the tic-tac-toe already done for my development project. But we're going to do from beginning here and create a new project. But before we can do this, actually there is one more step we need to do: how to install Firebase SDK to our iOS project. And to find out that, you can go to the documents here, and then under the products, you can go to, actually not here, under fundamentals, you can do add Firebase to iOS, and it's supported for different devices here. And here you will see how to add this to your Xcode project, and the standard way it shows is using CocoaPods. But in this course we are going to use something called Swift Package Manager, and we're not going to use CocoaPods to install. Both versions are quite easy to do. But since in my previous videos I have covered pod installation multiple times, this time I'm going to show you how to do the Swift Package Manager, which is built in Xcode anyway. So if you want to do the pod installation, this doesn't really matter to our project as long as you get the Firebase working on the project linked. Everything will be same. It's just a matter of how you are going to install it. If you want to do the pod installation, you can continue with the steps here, or if you are familiar with CocoaPods, you can do it without even reading the steps here. What we're going to do is scroll down, and we should see somewhere here Swift Package Manager. It says learn more about Swift Package Manager and our guide here. By clicking that, it will show how to install Swift Package Manager, install the Firebase using Swift Package Manager. There is a step-by-step guide here, but for some reason the steps here doesn't apply to the beta version of Xcode that is currently already using. If you are using it, watching the videos in the future, and Xcode 13 is out and not a beta version, most probably these steps would work. Otherwise, you can just copy this link here. This is all we are interested in. You can just click on this button to copy that, and we can go back to our Xcode project. And here you can see, if I go to the packages as it recommends in Firebase, these things are not highlighted, so none of them I can click. They are all kind of passive. But what we can do is you click on your project name, then you can click on the project here, not the target, just the project, package dependencies. And under the package dependencies, we can add now packages by this plus button here. You can see by default, it takes me to my recently added packages. And if you are doing this first time, you shouldn't see anything here. If you have done any other packages through Swift Package Manager, you should see them there. If you don't have it here, obviously, if this is the first time, just click on the search or enter package URL and Command V to paste the link and just hit enter. This will bring you this Firebase iOS SDK, like I have highlighted now, and it's asked which version we want to add. What we want to make sure is to up to next major version and keep it by whatever the numbers give this to you. Maybe you are watching this in future and the numbers are different. And add to the project, this should be your project name here anyway, whatever you call your project, and just say add packages. This will take a few moments to get access to the link there, and because Firebase has multiple SDKs you can add, and you can see them if we go back. The whole list of SDKs, you can add them here, and we are going to choose only some of them that we are required. There is no point of installing all of them and making our project really big, so we are going to select only few of them. Just wait until it gets through, and you will be able to tick what you need by just putting few ticks next to the libraries that we require. Depending on your internet speed, this will take more time. I'm going to pause the video and then continue once the packages are downloaded and we are able to choose what we want. Okay, our application is running, nothing crashed. If you have noticed, after installing our Swift Package Manager using and installing extra Firebase libraries, it took quite some time to run our application for the first time. This is again only the first time. Once you launch the application, the other runs are going to be much faster. Right, so let's see how we are going to use our Firebase with our project. Let's first actually, if you are new to Firebase, this will be interesting to you. Otherwise, you can skip a little bit this section because I'm going to speak about how the Cloud Firestore works. Treat the Cloud Firestore like one big folder where you save your files. The big folder has a link to this database area, which is our main folder, imagine, which has a base URL to that database. And then what we're going to do is to create collections, which is in other words, how Firebase calls it. Imagine this is your main root folder of each section. So let's say we're going to have our game here. If you had users, you put the users collection. I don't know, if we had some winning stats, you would put there, or some offers, you would put all in separate collections. And then each collection would have a document list of all the documents, and the documents would have another collection. So it goes like collection, document, collection, this part, and then again document. And the collection is a folder, and the document can be specific document inside of which you can have another collection if you want to. But our structure is going to be like, we will have a game collection here, which is our game folder, and inside of that we will have all our games there available if the user wants to play. So in order to access our game collection, first of all, of course, we are going to create. The good thing is when you are using Firebase and you are trying to access some kind of collection, and if it doesn't exist, the code automatically creates that for you. So if we are going to access a game collection to write something to that file, and it doesn't exist, we are going to create that automatically will create that folder. So basically what the game collection would be is we will take our root folder URL that our Cloud Firestore has, and then we will add just the game or whatever you want to call yours. But for the sake of the project, to keep everything consistent, let's call that a game directory. So let's write a file that is going to give us these folder directories fast, so we don't have to type long root directory and the collection reference name every time we want to access our database. So what I'm going to do, actually, let's Command N to create a new Swift file. I'm going to call mine Firebase reference. Right, and let's right click and create a group from this and call this Firebase helpers. Okay, close on the side panel here. I need to import Firebase here, and then I'm going to create an enum as fc collection Firebase actually collection reference, and this is just a string. Okay, so here we are going to keep all the types that we want to save. So I will say case game. Oops, no. Okay, and this will return a game collection. If you had a user, we would say case user. If you wanted to save users here also, I don't know, if you had we wanted to save a car, you would say case car, or whatever you want to say. Just basically this will be the name of your directory for that specific thing. So I'm going to keep only game here because this is what we are going to use. The rest you can just add anything you want to. And then we will need a function that is going to return the full pattern to our folder, taking into consideration whatever we pass that we want to. Let's say we will have a base URL, and then we say we want to access the game, and it will take the base URL, add the game to it, and return it to us. If we had the users, we would say just we want to add the user, and it will return the base URL with user added to that. For our case, it's only the game, and it's pretty simple. I mean, the code is same. Actually, we don't have any other option to pass once we start calling this. So let's say Firebase reference, and we need to pass a collection reference, which is type of f collection reference, and it's just a string. So we just use this enum in order to simply select the game or any other option you have there, and it's going to return a collection reference, and we simply say return, and we need to access our Firestore, and then we say our Firestore initializer, and this will give us the default URL, and we will say just we want to get the collection, and we need to pass the collection name, and the collection name is going to be our whatever we are passing, because this is going to be dynamic, and we'll return whatever we pass here. We just add the raw value because this is just a string. All right, so this is our function. Every time we want to get access to our game, we just call Firebase reference, pass a game to it, and it will return us our already link to the full Firebase path. And I'm going to create another file here, which is going to be our main things that will happen with Firebase, all the communication, all the checks, everything will be in this file. And it's a Swift file. I'm going to call this Firebase service. which we can use in order to keep everything nice and tidy. In order to use Firebase, we are going to, of course, import it. And we're going to also import Firebase Firestore Swift. This is very important. Make sure you import this. And foundations we have. Yeah, let's create a class. Call this Firebase service. And this is going to be observable object. And let's actually import Combine as well, because what we need is every time our game object will be updated, and the update will happen every time our user through playing clicks on any of these marks, it will be updated, or the user will quit. Whatever happens by the user done here, our game object will be updated. So we want to get that game object updated and tell our user that this game object was updated, so we can update our UI as well. That's why we are using it. We are passing that this is an observable object as well. So I'm going to create my static initializer, because this is going to be a singleton class. Oops, static let shared equals Firebase service, and we're going to initialize it. And to do that, I'm just going to create an empty initializer, so we can have only one instance of our Firebase service class here. Okay, and there will be only one thing our Firebase service class is going to update, and this is a game object as stated before. So we'll say at published var game, and this is type of a game, and this is not an optional, because without a game we don't really need any of this, and the application is not required because we cannot play our game without having a game object. So this is our Firebase service helper that we are going to use in order to do all the communication with our Firebase. So now let's talk about a little bit of our steps, what we need to do every time our user starts the game. Let's go to our game here and let's click quit. So what we want to do when our user clicks on play, we want to make sure that there are no games available now that we can join. So the first thing we need to check if there are any games already started that the other player is waiting for a second player in order to join them, and we can start a game. So first we check if there is a game that we can join, and if there is a game that we can join, we will join that game. We will update that game with our user parameters that has joined the game, and then we will move in to start the game and play that game with the other user. However, if there is no game currently available to play, what we want to do is to create a game, and then we will just have to wait until someone else's wants to play a game and will join our game. So it's kind of creating a game room and waiting like when somebody else will join the game. If there is no user and we are creating a new game, we need to start listening to any changes happening in our game object online, because whenever our other user joins the game, we want to be notified that some other user has joined and we have complete now and we can start game. So we can show it to our user here that we are not waiting for a player, in fact that the game has already begun, and this spinner will disappear as well since the game is already started. So in order to update our UI, we need to keep listening what other changes are happening to our game object. The other thing is once any of our users click on a quit, again, we need to inform, we need to first delete our game and then inform all the parties that are playing the game that, the other person has left and there is another player to play with. So basically you have to quit the game. So this is the game logic that we need to implement when we click our play button. And to do that, we are going to write some functions that will do all these checks and will help us establish the current mode of the game. Let's write the functions that we are going to use. So first one is going to be function create. Let's call this create online game. I'm not going to complete the functions. I'm just going to write each function that we are going to use in our game logic. So this function will just create a new game if there is no game ready. Then we will have a func start game. And this function should take one parameter, and it should take a user ID, because when we start a game, remember we talked about it last lecture, what we want to do is to check if there is an available game already so that we can join. And to join a game, if we find any available, we need to join with our user ID. So we need to pass it here in order, if that is the scenario, we are going to use that user ID in order to join the game. If, however, there is no game, we will again use that user ID in order to create a new game when this function comes in handy. So let's say with user ID, which will be a string. So this will start the game. Basically, this would be our entry point. When we click on a play button, it will start the game. So let me put a comment here. Check if there is a game to join. If no, we create new game. If yes, we will join and start listening for any changes in the game. So this is what we need to do in this function. This function is straightforward. Create online game. It's basically will create a new game for our in our database. Then we will have a function called listening for game changes, because we want to do this part, start listening for any changes in the game. So let's write this function. Okay, this function also doesn't take any parameters. I'm going to keep that empty. One more function is we need to be able to update the game, because when we join a game, and this is the join part, when we join a game, we want to take the game object and update the parameters of that game. So if I go to my model here and select the game here, by default our game, if it's already available, will have ID, the player 1 ID. This is the player who creates the game, and then the player 2 ID would be empty string. Block move for player, this will be empty string as well. Winner player, this will be empty string. This is by default. And rematch, this will be an empty array, and moves would be empty array of nils. Actually, it's not empty, it's array of nil 9 nil objects. So when we update our game, we are going to update it once a player joins, once there is a move registered, or the game has finished, or the block user, because every user has his with and we are going to update the game all the time. So this function would come very handy in order to update the game with the changes. And finally, we need two more functions. One of them is going to be func create new game, and this will be with user ID, which is a string. Okay, this will create a game object, and create online game will save the game online. So here we will just pass our parameters to create a game object. Okay, so this class only knows how to create game objects, and this class knows how to save them online. And not class, sorry, functions, because everything is in one class here. And finally, we need a func to be able to quit game. Once our user clicks on this red button to quit the game, we will quit the game. So these are all the functions we need. That basically describes our game, how it will follow. And now let's start with the start game function. So what we need to do here is we need to do a query. We need to ask our Firebase if there are any games available that we can join. And here is one of the places that we will use this Firebase reference thing that we have created here, because we are going to access the game collection of our Firebase. Let me go to my... We're going to access it here, and there will be a game anyway once we start, and we will ask there if there are any available games to join. So let's write the code for that. I'm going to access my Firebase reference. Firebase reference, and if I click dot here, it will give me all available options. In my case, it's just a game, because I have only one option there. And this is basically my full link to my including base URL, added the game object to that. And I want to access this, and I want to say where field is equal to. And let's see, field, not even, not in, field is equal to some kind of value. So the field is string, and is equal to is any. So this is what we need. What we are looking for here is we want to join a game where the player2 ID, imagine if we have a game object saved on online. Once we do the first game, I will show you also on Firestore. So we want to join a game that the player2 ID is empty string. So there is no player2. Because if there is already a player2 to that game, we don't want to hijack the game and override the player2 ID and start playing in their place. So we want to find the games only where the player2 ID is empty. So we will do here, I like to copy and paste these things, because if there is a typo, then this wouldn't work. It wouldn't find anything anyway. So we say that the player2 ID is equal to empty string, because this will set by default when we create a new game. All the player2 IDs will be empty string. And we want to filter it down further. So I will say where field, and then again we need field string is not equal to this time. And the reason we are choosing this is we don't want to select a game to join a game where we are also the player one. So imagine I open a game and then I leave the game without anyone joining me. So there is a started game hanging on, let's say, Firebase in our cloud. And then the next time I come out and I click on play game, I don't want to join my own game where the player 1 is me and the player 2 is me as well. So I want to make sure that I want to join the games only where the player 2 is not set yet and that the player 1 is not me. So I will say this is a string, and let me just copy this, paste it here, and say player 1 ID is not equal to, and this is where we pass our user ID. So it's not equal to our current user ID. So we don't want to join this game. And then whatever is left, we want to get all these files. So we say get documents, and you can just hit enter on it, and it will give us a query snapshot and error. We will receive two variables here, right? So the first, you can give them any names you want. I'm going to call them query snapshot and error. Okay. First, we want to make sure we check if there are any errors or no. We say if error is not equals to nil, let's print the error so we know that there is something went wrong and there is an error, etc. So I'll say print error starting game, and I can access my error here and get a localized description, which will basically convert it to a proper English and that we can read and understand. And we want to exit. We say return, because if there is an error, we don't want to continue and run the rest of the code. And one of the scenarios that there will be an error is when there is no games at all, or not even a game collection here. So it may give us an error. So as long as we cannot join any game for any reason, if it's an error or if it doesn't exist any reason, we want to create a new game. All right, so here we are going to create a new game. We already have this handy function here that we can call actually. So let me call it. So self.create new game with user ID, and we can pass our user ID here. Okay, this is the second thing we are going to look at it. If, however, there are no errors, it means that we have some kind of information back from our Firebase, and it can be an array of game objects that are in our Firebase, because there may be more than one game available. So what we need to do is we need to check if there are any games, and we want to choose the first available one, because if let's say it returns 100 games that are in waiting mode currently, we don't want to go and choose 20th or whatever the number. We want to choose the first one, because we are sure that if there is something, the first one is always there. So we'll say if let game data is equals to, and then we access our query snapshot here. And our query snapshot is an optional, and it will have something called documents. And the documents you can check here, it is an array of query document snapshot. This is a type of object provided from Firebase. All we need to know that this is an array of documents, and we want to access the first one of it. So if there is a first one, it's okay, we can continue, because we want to grab the first one. We don't care how many there are, we just want to get the first one. And if we can grab that, then we have a game object. So let's take whatever the Firebase provides to us, which is basically a JSON data, and we want to convert that into a game object, because this is what our model is familiar with. We have this game object and we want to work with game object. Let's go back to our code here. So what we need to do is we need to take this game object that we have and assign it to whatever we just get from our Firebase. So we say self.game is equals, and in order to decode our JSON into a game object, we need to, it may throw an error, so we need to put it in a try block. So we say try question mark, and then I will access my game data, and then we need to get the data from it. And if you select the data, you will see that this is a type of dictionary, string as a key and any object as a value. So this is what we need here. But there is a handy function from Firebase that can convert automatically into our requested object, struct in our case, which is our game, that you can choose this data as, and it says that data as type of decodable protocol. And remember, our case game object conforms to codable, which is encodable and decodable. And this will be automatically converted for us. And it says it may throw. So that's why we're doing the try thing here. And what we want to try to decode it to, we will say we want to try to convert it to game.self. So this will try to convert whatever we got from Firebase into a game object. And if it's successful, it will assign that game to our game variable here. And remember, this is a published, so whoever is listening, we will update that game. So every time there is a change, we will automatically update this game object, whoever is listening. Okay, so we found the game that is available that we can join. So what we need to do, we need to update that game. So we say self.game, and then let's put our player ID 2 is equals to whatever the ID we have passed here, the user ID. So we say our user is the player 2 now. So we have updated the player 2 ID. And then we want to block the moves for our player because we are the player 2. And remember, we are player 2, we assign to have the O or 0 mark. And usually the tic-tac-toe, the first player is the one who uses the X mark. So we say self.game.block move for player ID equals to user ID. And we will block the player ID for, we will block the moves for this user. And now we have updated the two parameters of the game that we needed. Let's jump to our game model again. So we have assigned our player 2 and we have blocked the move for that player, right? So the two things were updated, and what we need to do now is update our game object so that the Firebase on our cloud object will be updated as well. So this is, let's see where it is. Where is our update function? I thought we created this update function as well. So I don't know what happened. Let's write a func update game, and we are going to pass a game that we want to update. Sorry, my bad. I thought we wrote this function here. So we say game, and we will just pass a game here that we need to update. So that this function will take the game object and do the update in our Firebase. So we can call that function here. We will say self.update game, and we need to pass a game. And the game will be our self.game object because we just updated the parameters of that game. And finally, once we join the game, we need to start listening for any changes that happen in that game, because we are now part of the game and we want to get all the updates that our game will receive. So we will call the function self listen for changes in the game. Okay. This is the if we find anything in our query data. Else, if there is nothing in our Firestore, what we want to do is we want to create a game. We want to create a new game, and then we would be just start listening for the changes. So I will call the same function here, self create new game, and then this is all we need in our function here. All right. Let's quickly go over the function again and see what we're going. We call the start new game and we pass our user ID to it. Then we check if there is a game to join. And the check is here. We access our game area where the player 2 is not existed. So there is no player in the game, and that the player 1 is not our current player. So we didn't start this game. We just want to join the game. And then we grab all the documents that our Firebase have for it. First, we check if there is any error. If there is any error, we will print an error, and no matter what the error is, we cannot continue. So we just create a new game so that our user can start waiting for other player to join his game room. Otherwise, if there is no error, we will check if our query returns any game objects from our Firebase. And if it does return, we will just grab the first available object in an array, because this returns array of any results there is. And if there is a game object, we try to convert this dictionary to a game object that we have in our model. And if we are successful, we will update that game with player 2 ID. We will assign ourselves as a player 2, and then we will also block the move for ourselves, because we don't want to play as a player 2 the first. And then we call an update game function, which basically doesn't do anything for now. And also we start listening for any changes happening in that game, which again we call a function that currently doesn't do anything. So if however we couldn't find any object returned from our Firebase, this could be the scenario when there are no games available to join. We want to create a new game and we just create a new game, and we will start listening for changes in that game. Right? So this is our start game function. In our next class, we are going to write the function that will create a new game and will save it to our Firestore, so that we can also visually identify how the things look in our cloud Firestore. So let's go down to our create new game function. And here we are going to create a brand new game which doesn't exist, and we're going to assign our current user as the player 1. I'm going to just put a print statement here, and I will print creating game for user ID, and let's pass our user ID here, just to have a print statement that we will see that everything is going as we have planned. Then I'm going to say self.game is equals, and let's create a new game object. And we have this initializer ID. I'm going to assign a default randomly created ID. So let's get a UUID, and we want a UUID string here. Player 1 ID. This will be the ID of my user that I pass. Remember, player 2 ID, we always set it empty string for our initial game creation. Block move for player. Here I will put my user 1, because on the state that no one has joined the game, I don't want my user to be able to play the game, because this will automatically update the objects of the game online, and once the other user joins, he will get the latest version of the game object, and this, let's say, Foursquare will be already taken. So we don't want to do this. Then we want to block our player, and we wait until the player 2 joins the game, and then we will update the block move for player 2 to be able to play our current user, which is the player 1. So we will remove our user as the blocked here, and we will assign the other user, which will be the player 2. Winning player ID, obviously it's a brand new game. Winning player ID will be empty string. Rematch player ID, again, it's a brand new game, so we will pass an empty array here. We don't have any users that have requested a rematch. Moves, here we need to pass array of 9 nil objects. So I will say array, and we are going to say repeating. What we want to repeat is nil. How many times? 9 times. So this will add an array of nil objects to our moves here. Okay, so the new game object was created and it was assigned to our game here. That is our variable, which is published by default. So now the next step would be to save this online. So what we do here, we call our handy function here, create game online, which will take the game object and save it online. So we'll say self.create game online. We'll call this function. And also we want to listen for any changes happening to this game, because if we enter the game, there is no one to join, we create our game and we are sitting and waiting. We want to be notified when somebody joins the game. Otherwise, we would be waiting forever, because if somebody joins the game and we are not listening for any changes, obviously we won't be notified. So we say self.listen for game changes. And that's it. This is all we need for our create game function. And now the second step is to create this online game. Let's jump to that function and see what we need to do. Remember when we were accessing our, this is basically like fetching game from Firestore. We saw that we receive a key value pairs dictionary from our Firestore. Basically what Firebase does is saves dictionaries online. So we were able to decode that into our game object using this handy function that is actually part of Firebase Firestore Swift. So now what we need is we have a game object. We want to save it to Firestore. So we need to encode it into a JSON so that we can save it to our Firebase. And to do that, again, we have a handy function from Firebase Firestore Swift, but that may throw an error as well. That's why we put it into do catch block, so we can catch the error if there is. And I'm going to say try. And we need to, in order to save something to Firestore, we need to tell where we want to save it. And remember this part here, when we are querying our game, we are querying it in our game directory. So it will be smart to save it also in the game directory, yes? So let's access that, say Firebase reference game. And then what we want to do is to create a document there. So we say document. And if you choose the second one, the document path, we will be able to tell the name of our document we want to save. Otherwise, you can leave it to Firebase in order to auto-generate this document ID. I'm going to choose to set the document name myself, because it will make easier for me in order to grab that document later on, because we will use it for our quit game function. So my document name that I want to set will be my game ID. So I will say self game.id. So we will create like a document with the name of the document being my game ID. And then we want to set the parameters of that document. The parameters would be, let me go to my model. It would be like ID is whatever the ID is, player 1 ID, whatever the player 1 ID is, etc. It will be like key value pairs there. So we want to set that. And I will say that I want to create data. So we say set data, and we have different options here. The one we need is that the one says set data from, and it says throws. And if you check down, it says we can pass an encodable object here, which will be converted into a key value pairs automatically. So what encodable object we have is our game. Remember, our game conforms to the protocol codable. If we click and jump to definition, it will just be decodable and encodable. And to encode, to save something to our Firebase, we are going to encode it into JSON, and to fetch it back and convert it to a game object, we are going to use the decode part, and then we decode it into a game object. So this basically tries to save anything to our Firebase. If it fails, again, we just print our error and get the localized description, so it's easier for us to understand what's going on. So this is all our function needs to do, right? We are calling it as well. So yeah, we have two handy functions, and I think now we can also test our start game, which obviously wouldn't find anything, and it should be able to create a game online so that we can look into it and see if that works.